Okay, properties of exponents. There are four basic properties of exponents you'll need to know going forward. We have two factors here, an x to the fourth and an x to the third. Each factor has a common base of x, so I write x down, and in multiplication I combine them by adding the exponents. 4 plus 3 is 7. Now why do you add? Well, x to the fourth is 4 factors of x. X to the third is 3 factors of x. That adds up to 7 factors of x, or 7 of them. Now in the next problem we have x to the fifth divided by x to the third. Now, in division we subtract, but you have to subtract in a certain smart way. You cross out the smaller exponent, the base with the smaller exponent, you cross out and you subtract it from the other side. 5 minus 3 is 2. So x to the second is the answer. Again, why do you subtract? Well, x to the fifth is x, 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 x. X to the third is x, x, x. The common factors cancel and we have x to the second. Okay, now in the next property, we have a parentheses with x to the second power, and then outside we have a third power. So it's an inside-outside power. So I write the base down, and what I do is I distribute the powers, which means I multiply. So 2 times 3 is 6. And why can you do that? Well, x second to the third would be x second, x second, x second, and then all the x seconds go to x times x, x times x, x times x. You don't need to write all this stuff on the side. Okay, x to the negative 6 power. Now, with a negative power, you need to make that negative a positive by what's called reciprocation, meaning we will put a 1 over it, and it makes the negative 6 a positive 6. So the answer is 1 over x to the 6th. Now I want to apply those properties with some numbers. We have 2 to the second power times 2 to the third power. So we have two factors, both with the same base. Okay, a 2 and a 3. So I go 2 plus 3, that makes 5. I want that circled. That's part 1 of your answer. If it's not there, I'm going to count it wrong and you'll receive no points. 2 to the fifth, in the second part I want 2 to the fifth evaluated. 2 times 2 times 2 times 2, it's 32. Okay, 2 to the sixth divided by 2 to the second. Now, remember how we divide. As long as we have the same base, we take the smaller 2 to the smaller power out and subtract the 2, and 6 minus 2 is 4. So that's 2 to the fourth. And then 2 to the fourth evaluates to 16. If you're putting 8 down, that's ridiculous. I'm sorry that it is. No excuse for that. It's 2 times 2 times 2 times 2. That ain't 8. Okay? Now I have a parentheses 2 to the fourth, and then outside I have a second power. So I write 2 down and I distribute the exponents. That's 8. And then 2 to the 8th power is 256. Then 2 to the negative third. Now a negative exponent, we make a 1 over it and make it positive. Okay? You can circle that then. But now you have to evaluate 2 to the third. You're still going to have the 1 over the product, but 2 to the third is 8, 1/8. You write 8 down, it's wrong. It's got to be 1. Then the final property, anything to the 0 power is 1. Okay? You don't have to do any work. If you evaluate one single basis to the 0 power, it's 1. Okay, why don't you pause the video and do 1 through 4 on the back there. Numbers 1, 2, 3, 4. Okay, 1 through 4.